Hi from my side, my name is Sebastian, and I have the pleasure to talk about applications with graph databases and what that is, especially with these interesting technologies called Neo4j and Quarkus. So I was already very nicely introduced. My name is Sebastian, originally from Germany. I am, basically doing a lot of stuff with Java, as you can see with these titles here. So, I help companies and my clients with being better as a Java developer, mostly in the enterprise space. And I also happen to give some presentations and talks. And today I want to talk about, why we should care or why we might care about graph databases, particularly Neo4j, and particularly because, I'm a Java developer, how to use this with Java and how to use this with Quarkus, with this enterprise platform. And luckily, I don't have many slides for you, so pretty much everything will be live coding and live demos. So what you mostly will see is my IDE and some projects. So I want to get into the code and the examples that I have right away, because I think this is the best way to somewhat get an idea what that is. So what I have, this is a Maven project that, of course, so you can get all of the code later on GitHub. So all of that is open source. You can have a look at it and, of course, try it out. And also, if you know about me, I'm a coffee lover. So this project is called Favorite Coffee. Favorite, why? Well, because we will include some sort of recommendation engine that where we use a lot of feature from this graph database approach, especially when we then have a look at how to use this graph database that we will see in a moment. We will see how this is a very interesting way to query some more complex queries or more complex approaches. So what I will use for this is a Quarkus project. So what Quarkus is an enterprise runtime that builds on Java Enterprise APIs. So you can check out this particular project. I use Java 16 and Quarkus in a recent version. And then I will show you in a second how we use this Neo4j approach. But for now, for you to get an idea what a graph database is, let's start with this one. I included some shell script to run a Docker container with a Neo4j database. It looks, this is starting up. It looks roughly as follows. This shell script is a little bit cryptic, but basically what it says, Docker run some Neo4j in that version, and then please just start it up and also already import some data that I have. So some example data here that I will use for this coffee example. So let's wait until this is started up, and then I can go, and this is already an interesting thing. All of the Neo4j databases come with a browser. It's called, Neo4j browser that you can open up in your browser, and that then you can use to explore the database, just like a database browser. But in the beginning, this is very helpful because you will see that this sort of visualization of what you have is very well understandable. It's very comprehensible. So what do we have? We have some sort of, that is a part of, it's called Cipher script. So Cipher is the equivalent of SQL in a graph database. And we say match, and then there is this type coffee bean. We will see this in a second in the code as well. That just displays, it is somewhat, a coffee bean. So what does this mean? If you go to a nicer coffee shop, often you can choose the beans. So for example, you say, I really like this coffee that is from Colombia or from Ethiopia or from some other country that produces coffee. And typically, if you are more a coffee connoisseur, you will also understand coffee has very different taste. So actually, the taste of coffee has more variety than in wine. So with coffee, it doesn't just taste like black coffee. Coffee is really interesting in taste, and it can taste very fruity. It can taste chocolatey, or like flowers, like berries, and all of that. Here we want to somewhat represent. So, for example, I have certain coffee beans. So these are they are like nodes in a graph, just a bubble. But then, of course, the power of a graph database are the connections, like the edges. So if I make a double click here, and I will just take this here so that it's a little bit more comprehensible. What do I have? I have a coffee bean here, all the orange things that just has some name. Here's some Spanish name. And this one has some information. So you can see this down here. The node itself has some properties like a name, a UID, and things like that, but it can also have some relations. And the relationship here are literally these arrows in the graph. And you say, well, this one here, it's written tastes like a specific, this is called flavor, like a specific taste. And then what you can do, you can say, well, this coffee tastes like a floral taste, you know, like some flowers, some florally taste, or like some fruity taste. And then you can model what that relationship, looks like. And if you think about it in a very naive way, this is always somewhat comprehensible because you can see, okay, what is going on here. And then also, if you can read it down there, I think I have to scroll a little bit. Here you see the percentage. So you can say percentage 30% and 70%, because you can also have something like a flavor distribution. You can say, oh, it tastes more like fruit than like floral and things like that. So it's you can really get into detail and then says, okay, what does this bean taste like? And also you have another information. This bean is from a specific country, like it is from Colombia. Okay, so this is basically a modeling of the data, how this looks like, and what you can do then in a graph database. So basically that's the data model, just as a very simple example. What this looks like in a Cipher code, so I have my example data. This looks in the beginning a little bit interesting here with the specific data, but basically you can say this is the Cipher script that creates it. So you can say, well, create this particular entity, this particular node in the graph, and then you can have some match and merge statements here for which you can say, okay, include. And this is written almost like an ASCII art. This is an arrow. This relationship is from, C is this country, so it is from a specific country in origin. And more interestingly, we can have some flavor, tastes, which also has the percentage here as this relationship property. So you can say this coffee tastes like fruity taste, like floral taste, to so and so much percent. So that's basically what we can model here. All right, that's the very basic modeling, what we use just for the database. We could spend a lot of time talking about specific Cipher queries and how to use them. But now I would just want to switch into the Java world and say, okay, now we have a database that is running in a Docker container. And how can I access it in my application? And how can I use all of this data and interact with it? Well, this is where this Quarkus comes into play, because I have a Quarkus application. If you don't know what a Quarkus application is, well, it looks a little bit similar to a Spring Boot application or a more traditional Java EE or Jakarta EE workload. So we have some sort of enterprise system, some enterprise application where we want to access not a regular relational database like a Postgres, but now our Neo4j database. And of course, there are some dependencies for that. So I could say, well, use this dependency. This one is the officially supported for Quarkus, Neo4j OGM. OGM is like ORM for the graph world. So object graph, I think, mapping. So I can map these graphs into my Java objects. I'll show this in a second. And then internally, it will use some, it's called Neo4j OGM, these dependencies that you can use as such. So that's one thing here. And also this Quarkus integration already integrates with my Quarkus application, and especially will use one type that I will show you in a second. So just let's very quickly go through some code, and I can say, well, for example, this, if you haven't seen a Quarkus application before, this is a REST controller, something like a Spring REST controller or a JAX REST resource here in this way. So if I access my application and then beans, for example, I can list the coffee beans. Let's try this out for a second. So I can say, please start up my Quarkus application in a development mode. This is typically what I do when I code with Quarkus, because then, well, I can start this up and I can, fire against my application. But also, well, you see typically Maven, first of all, downloads the internet. But then also I can query the application and see what is happening, and I can even change code. So if you're not familiar with Quarkus, then you definitely should check it out. You can just Google for this name Quarkus or go to quarkus.io and then start developing Quarkus enterprise applications, because this is really interesting what this Quarkus way enables for us. Okay, so now it's started up and we say localhost 8080, go to beans, for example. And then we already see, there's some beans here. Let me print this with some JSON output. And then we see, okay, we have, for example, some bean that has this name or this name. It comes from an origin country and it has a specific flavor profile. So it tastes like fruity flavor and floral flavor and so on and so forth. So this is the same information that you've seen in the graph database. Okay, how does this work? Let's have a look at the code. If I go to the code, I end up in this resource. I say, well, beans. And then this is the method, get coffee beans, that just returns from this particular, from this bean, this CDI bean, it returns the list of coffee beans, so different beans here, because Java also has beans. And what it uses a so-called session factory. So this is the most important way how to interact with Neo4j OGM. This is a type session factory that comes here from Neo4j OGM. This is a little bit similar like an entity manager or like a Spring Data repository. This is injectable thanks to this extension that we use. So we don't have to do anything. We don't have to configure anything here. In order to get it started, the only thing I have to do is to include this dependency and then to set the properties right. If you know about Quarkus, then this shouldn't be a surprise. There is a file application properties, and here there are some certain somewhat default properties that it can set. They usually start with Quarkus.something and then Quarkus Neo4j URI. You will have the URI username, password, like just typically in an enterprise application when accessing a database. And that is how we access the database here. So the one that runs localhost in our Docker container. So this is how that works. And then out of the box, this already works with injecting the session factory and then saying, well, in order to get the coffee beans, I typically go and say something like session, open a session, and load all of the coffee beans here. And this is then also quite interesting. This integer, the 1 at the end, is the depth, like how much we would like to load here. And then you have to look into the graph. So basically, how many hops in the graph do I want to load? For example, if I have my graph here and I want to load this class because this is the coffee bean and that is mapped to a type, I will show you the entity in a second. And then this is one hop from the node to here, for example, the flavor. And now if I would like to load the next one, recursively or with more depth, I would need to go down that route and then, configure how many hops I would like to have. But for us, this is sufficient because I mainly want to have this domain object here, plus, of course, the populated fields or the populated relations. So how does that look like? If we go here to the coffee bean, in a second, did I make something wrong here now? Or now there's like a compilation errors. No, I think this is just in the IDE. Okay. Coffee bean. This is interesting. Node entity. If you have a look, ID, this looks very much like JPA, right? So this is also a declarative mapping similar to what we have in the ORM way with JPA or with Hibernate. And with this, we can just define all of these, properties or relations for this particular node. So this will be a node entity in our graph. And we have seen these. So these are all of the orange dots in my graph. Plus, the entities, that's quite straightforward. So like a name. But the relationships, these are also interesting. So this is a little bit similar to a one-to-one and many-to-one mapping in a database. So here I can, for example, define what this relationship looks like. And then I could also say, okay, what is the direction and so on and so forth. So from how is this mapped? So that's basically this. And I can also define something like a flavor profile. This is needed relationship entity if my relationship already has a property like my percentage, which it does. So then I need not only use a Java reference, because in a Java reference I cannot have a property or something like this. I of course then need another intermediate type, which here is called flavor profile, that just says, okay, how much percentage do you taste like a specific here end node flavor? and then I can use this in such a way. So this is how this is typically mapped, or I mean, this is one example how this OGM way is mapped in our Java code with our domain model of a coffee bean in a specific flavor and a specific flavor that tastes up to some percentage to about or like a flavor, which is then mapped in this relationship entity. Okay, so this is how we can map that. And then what happens, this is quite cool. All of these properties here will be already provided by the OGM loading. So I don't have to set all of these. It just depends on the depth, how much I want to load. And then they are returned from this method, get coffee beans. Here with without a sort criteria, I can sort them by specific things, which you can see here. I will show this more complex stuff in a second, but the easiest way to load that is to use the typed way of a specific, well, type of a node. Okay, so we've seen that this already works. Let's go into a little bit more interesting examples. So if I say, please load all of the coffee beans, okay, that's quite simple. But now, because for now we could do the very same thing with a relational database, right? That's nothing that special. But now the more specialities come in. What happens if I say, get the coffee beans that taste like a specific flavor? For example, I would like to say, get a flavor. And then the flavor should be, this is a query parameter. So say not just all coffee beans, but coffee beans with a specific flavor equals fruit, I think was the name. And then we get only 2 beans. So instead of all of them, I only get the beans that have at least some taste of fruity flavor. So not the other ones. These are only, in total I have 4 or 5, 4. And now I only got 2 because only the 2 ones that taste like fruit. Okay, how does this work? Because now this is a little bit more interesting. Now, this typed query approach of this OGM mapping gets you usually only so and so far, because then you say, well, I need to provide more interesting information. And this is typically done in the Cipher query approach that I've put into this Java text block here of saying, well, match. And now if you're new to Cipher, don't worry, but I think this is somewhat comprehensible because it's very descriptive, this language. So match something like select all coffee beans, right, that tastes like a specific flavor. And the flavor I can provide like a SQL query here, flavor name fruit, for example, the one that is provided here. Okay, so that means match all of the coffee beans that take a specific flavor, that taste like a specific flavor. And this is already it. I can actually, this is a very good tip for you if you want to try out your queries, if you're not sure about all of the syntax of a more complex query. The best way to do that is to just go into your Neo4j browser and put them in. So if I say fruit, I put them in here, and then of course I need a return value. So I say match b coffee bean. So this is like a variable of type coffee bean. For this whole statement, for this whole structure, match this whole structure, a coffee bean, but only one that tastes like a flavor. So this is like a where and end statement all in one. And then return this coffee bean. And then we see, okay, now we only have these 2 dots instead of the 4. So this is already it. Okay, now you might say, well, if it's so simple, there's just this one line, why is my Java code a little bit more? Well, just for the fact, if I do this myself, the only downside of it is I have to include more information that then automatically will be provided into my model. Because if I don't do this, then I only get the coffee bean here and the flavor. And then my response wouldn't be correct. Then here there wouldn't be fruit and floral. Otherwise there would be only fruit, and this is not correct, right? So I say select on something first. The something is my bean, and then load all of the data of this bean again to populate each and every bean that you've selected correctly. So in other words, I say match also here the country and match also again all of the flavors, not just the one that I want, but all of them. And then return, this looks a little bit weird at first, all of this collect statement, but that basically what it does, it collects and returns one single line with all of the information for one bean, like in one row, like in one return statement. So if I go here and take, for you just to show you, if I take the whole statement and try to put it into the browser, then it does exactly this. It gives me the whole structure here that then will be populated. And it's more obvious if I switch to the table mode. Then I see, okay, this looks a little bit weird in this JSON format, but I basically get one line per bean. So the bean here is the first one here, and this bean down there is the second one, and that's it. So this is all in one line, just collected as an like a nested list. So that's quite interesting. These two entries that are returned will then be automatically be mapped, and that's the cool thing about this OGM model. These coffee bean results will then automatically be mapped. I can put them into a list, and then that is returned here. Okay, so far so easy, so far so good. This is the way how to put in more complex queries, like my own queries, where I can query for literally anything. Here in this way, I query for a coffee bean, and then I say only return these specific ones, like for example, for a specific flavor and for a specific string. Okay, while I'm changing something, you can maybe think of some questions that will be answered in the end. What I now do, let me reset the database again, because now I only had 5 coffee beans. That is a little bit boring. Let me start and run my example again with more coffee beans. Because what I did, the first example I just invented myself. I invented some funny names. But now for the second example, I actually, well, I scraped some website to get data of many coffee beans that you can actually buy. So it's more interesting, because then we will build up, so there are almost 100 coffee beans that I will now load up from a CSV file here, and that will be loaded into my database. So once the database is up and running, now I have much more data. So I have many coffee beans. These are only limited to 25, but doesn't matter. So I have many beans that taste like, you know, something. So here you see this is a very complex graph. This is why I didn't show you this in the beginning, otherwise you wouldn't have a nice overview. But it's still the same idea. Now it's the flavors are called a little bit differently, like fruity, earthy, winey, buttery, and so on. But it's still the same percentage model. So I can say, okay, up to so and so much percentage, it tastes like specific things. Because now what I can do, just for you to show, I can say, I go to localhost 8080, I also have an index HTML page that actually uses a Quarkus template. I can show you this in a second. This is just what is called a controller here with Quarkus, with this Quarkus Qt template, which is a really cool approach as well. So I can include the whole thing in for an HTML template here that resides, if you want to check it out, that resides on the templates index. And I say, well, go through all of the coffee beans, and then say, well, what do I have here? So that's just very much the same thing. In the controller, you see it also says get the coffee beans. It's the same method. But then what I have all of these information here, and I can say, well, these are coffee beans. They are from a specific country, and they taste like a specific flavor. Okay. So far, so easy. Same thing, just more data. But now what I can do, I can make some rating here, like a 3-star rating, bad, so, and really good. So this means if I try a coffee, for example, you know, you go to a nice coffee shop, you say, well, hello, I would like to have this particular coffee. And then you try it out and you say, how much do I like it, right? So this is a little bit like buying something on Amazon or some online shopping. And then you say, how did you like the product? And people who also bought this product also bought the following. And this is then where we get into the idea of a recommendation engine or approach, where we say, okay, now it gets interesting. How can we just recommend something? So for example, if I say I try out this coffee, and for me, for example, I really like a fruity taste. So let's say I try it out and then I say, okay, good job, now 3-star. This page just quickly reloaded and you see, okay, this is now saved. I have a user rating where I say, okay, I rate 3 stars. How does this work? Of course, the user rating is also part of my database. I quickly show you this. I have an entity user. Here, in my case, I only have one user. Of course, you could have it per user, but for now, we only have one user and a specific user rating, which is quite easy. So the rating is either well, good or not good. So I only say 1 star is bad. 2 stars is like so-so, it's like neutral, and 3 stars is really good. So positive, negative, and neutral somewhat. And then we could say, okay, I do this maybe 2 more times. And then the interesting thing is, let me search for some other, maybe this one, fruity coffee, and then maybe some other coffee here. So now I just rated 3 coffees. And then what I can say, sort by, instead of name, sort by the rating. Okay, this is quite easy. So I can sort by the rating. So all of the ones that are rated. So maybe let's have something that is just 2 stars, like here. And then, of course, it's just rated and goes down. Okay, easy. But now the interesting thing is recommendation. So recommendation is, these 2 are pretty much at the top. So here you see, okay, fruity ones. And then here, the other ones we see, okay, they are also very similar in taste. All of them have somewhat fruity tastes, some flowery taste. They are all very similar from the taste. And down there, if I scroll down, then there is the spicy taste. And here it says, okay, spicy, earthy, chocolatey at the very bottom. So these are not rated, really well. And then if we say nutty and earthy, assuming I tried this Robusta coffee and I didn't like it, it only has 1 star, then you see how the rating changes. And this is now the interesting thing where we say what is recommended and what is the criteria that we would like to select on when we build some recommendation. And this is now getting interesting for our example. So what do we do? I say index controller, get the coffee beans. And if we say get the coffee beans sort by, let's start with the easy one, sort by rating. This is very similar to what I had before, just at the end that it says order by rating. Okay, so this is almost like SQL, very simple. Just say you have all of these lines, that's easy, and then just sort them by a particular criteria, for example, by the user rating. So it has one more match, the user that has a relationship rated, and then sort by the rating. So the rating is somewhere written here, rating sorted by this. And it's sorted in such a way that a neutral rating should be 0. And this coalesce function means if it's null or if it's not existent, then just put a 0 in between. So all of them have some rating. So either negative, 0, or like -1, 0, +1. Okay, so then it's sorted by this way, but very simple. The more interesting thing is not the rating, but the recommendation, because the recommendation is now more interesting. And now let's go through this. So this query at the beginning looks very complex and we're like, oh my God, right? But in comparison to a relational world, this is actually quite simple. It might not look simple on the first glance, but if we go through it step by step, it is comprehensible. Okay, what do we want to have? Okay, we want to say, please recommend some coffee beans. How do we recommend them? And this is, first of all, a domain or a business question that we need to understand. We have a specific domain model, like our coffee bean, and that has specific criteria. It could be the origin, it could be the flavor, and I think it makes sense to use the flavor, right? Because you want to try coffee that tastes good, that you like the taste, that it tastes, that it matches your taste. So it really makes sense to look at the coffee that you have rated and then say, okay, which flavors did you like? Okay, and then we use these flavors to say, please find me coffee that tastes similarly, where we have a similar taste, so similar flavors, and especially where we have a sorting, like a sorted by a weighting. So what tastes more like what are you more likely to like? So let's try this out. So first of all, we start with a flavor. Why with a flavor? Because this is the criteria that we want to select on, where we say, okay, match the flavor. And now, first of all, only get, and this is that structure here, get the coffee beans that have been rated, and of this coffee beans, get the flavor. So basically get all of the flavors that have been rated in some way, either positive or negative or neutral, right? Because something that hasn't been tried, I cannot use for a criteria. If you don't know if you like a coffee, well, then it's not helpful. Okay, then what we say, and this is now interesting, this really depends on the data modeling, or it goes into the data science world, how you want to work with the data, how you want to make the algorithms. Here I made the following algorithm. I say A positive rating is positive, so it should definitely show up stronger. A negative rating, well, is negative. And neutral is just like, neither way. So what I say, this rating is usually 1 to 3. So I say in this way, 2 stars is like neutral. So make it -2 so that we have either negative, -1, 0, or 1. Because then we can say this is a rating, and then we can make a flavor weight. So we use this rating multiplied by the percentage. Because it's not just that a particular bean has a flavor, but it also has that flavor to a specific percentage. So if you try a coffee bean that tastes like 70% fruity and then you like it, it's very likely that you like fruity taste. So we build the percentage of the flavor into it. Okay, I hope you still follow me. So what we do, we construct what is called a flavor and a flavor weight. And these with statements build basically tuples. So at first they say go over all of the flavors that have been rated and then calculate all of these weightings. So say, okay, this is 1 is basically 100%. So per default take 100% or take so and so much percentage. And then again, as I told you before, if you want to debug this, you can. And this is really helpful if you are trying out statements to just not take all of them. So it's really like a debug mode. So you can really step-by-step comprehend what the intermediate result is. So I can, for example, say return now this tuple of flavor and flavor weight. Let's do this. And then this is now not really helpful, but the table is helpful. Here we say I have a nutty flavor. Minus is negative, so this is rather bad because I gave this nutty flavor only 1 star. Earthy flavor, buttery flavor is kind of neutral. Spicy flavor, neutral. Winey, okay, kind of positive. Flowery, more positive. Fruity, very positive in comparison because fruity had many positive stars. And chocolatey, also either negative, so it hasn't been rated, or it just cancels each other out, that it's neutral. So it might not include all of the flavors, but that doesn't matter. Later on, we just need, a tuple of the flavor and the flavor weight. So this is like an intermediate result that then we can use to continue. So again, if you struggle with these complex commands, you can literally break them down line by line and say a return statement, throw it into the browser and see what you have. And then you really also comprehend whether it's correct. So this is really like debugging it. And then you see, okay, does it make sense? Okay. And then we say, please match all of the coffee beans, get the flavor as well, get all of the other information because we need it later on as well. So this is pretty much the same what we had before. The difference is that now we keep a weight. And the weight, it is calculated here at the end. We say we have a flavor weight, and then we take also the actual weight of this particular bean, how much it tastes like this flavor, right? So this is like a 2-step. At first, you see how much you like the flavor in general, and then of a potential bean, how much does the potential bean taste like the flavor that you liked or not? And then you also factor this in with that weight, and then you get the weight of the actual bean. And with this is now very similar to the result that we get. We can try this out here in the browser, of course, as well. I can say, throw in that huge statement, and then what you get is, first of all, a bean, a coffee bean like this particular one. It has all of the information, but this is not interesting. The interesting part is the weight here on the right. And this weight is very good because it's sorted by this weight. This is the highest weight in comparison. And then you get, smaller and smaller ones until you reach 0 and then negative ones. And this is exactly what we have here in this particular list, where we see, okay, now this is sorted. So that is basically a first approach of saying what is a recommended flavor. So you see, this pretty much matches the rating here. The 2-star rating should be somewhere in the middle. And then at the end, we have this 1-star rating of just that you didn't like. And then it makes sense that this is also somewhat at the bottom. Okay, I have 2 more examples here. If we go into this user profile, we see, okay, what did you actually rate before? So this should be, again, quite simple. We can say, okay, match the user ratings, then get the particular coffee bean for the user rating. But then also, this is quite interesting. It's almost what we just did. Based on your preference, these are coffee beans you haven't tried, but likely match your taste. So this is exactly the same like the previous table without the ones that we already tried, right? So it's new taste. Otherwise, it would be boring because I already know the result. But basically saying, hey, this is a new coffee bean. I'm pretty sure you like it based on your previous preference. So if we have a look at that, you can see the code for this, of course, as well. We say, let's go for the next controller. This should be something like a user controller, I think, user page controller. We say, okay, recommended beans, coffee beans get recommended beans. Again, you can check out all of the code on GitHub. Is this very similar to what we just had? We just say, okay, get all of this. But then at the end, where we match all of them, there's one more line where we say where not exists bean rated user. So here you see this goes very much to the into the area of SQL land, because here we say, I think this is very readable. Where not exists this statement. So where there is not a user rating for this coffee bean. So you can make exists on this sort of subquery here and say where this doesn't exist for that particular bean. So where you say, well, it has to taste like a flavor. Yes, all of them do. But this must not be rated. So only get these that haven't been rated, neither positive nor negative, doesn't matter, haven't been rated at all by this user, and only get them. So quite similar, almost the same statement to before, just with one more and statement somewhat. Okay, and one more saying new flavors. Feeling adventurous, these are beans with flavors that you haven't tried before. So basically saying what are flavors that are neither positive nor negative, that are somewhat new to you, that you haven't rated really before. So if there's something that you haven't tried. So how does this work? We have a method get untested coffee beans. We say, okay, first of all, match this flavor again. And now make the rating a little bit different. We say, take the rating as a percentage in any rating. So say, well, 0 is not rated. All of the other ones are rated. And where they are rated, just take them out or basically sort them with a lower priority. So what you end up with is just coffee that you likely haven't tried because you likely didn't taste the flavor. Of course, if you try long enough, at the end, at some point, you will taste all of them, basically. But this is just about new flavors that you haven't tried. So here, same thing. Match some coffee beans that you haven't rated, that you haven't tried before, and then return them. But now with an ascending weight. So the lower ones first, or basically the 0 ones first, and then limit here by 10. So we only have 10 results. And then this is the one that we actually didn't rate or didn't try yet. So these are some examples where these queries, and especially these recommendation ways, are much more powerful than what you could do with a relational database. So a graph database especially makes sense when you have these either complex queries or complex ways of accessing the data or some specific information about your data that you have, and then crafting queries based on that. Because the queries that I showed you, you might say, rightfully so, they look a little bit complex. But if you think about it, if I would write the same thing in SQL, it would, it wouldn't fit on 10 monitors. It would be, well, it would be much more complicated to write the same thing. So all things considered, this way and the syntax is, I think, still descriptive of saying, okay, please select the structure with these relations that we have, and then based on the relations, select and match something here. So especially where a graph database shines is in all of the relations. That's basically the most important thing of a graph database aren't the nodes, that's the relations and how the nodes interact. And especially relations that have percentage properties on it, like our percentage, they are really helpful because then we can query on them. And then as you see, we can use them for some more advanced calculations where we say, okay, we have some specific rating here, and then we can think of something that might or might not make sense in order to recommend them there. So that's quite helpful. Now, for the Java world, where this plays into this Neo4j OGM is in such a way that if we map and construct our entities in such a way that we have this declarative approach here, then this works quite nicely with the Neo4j integration, that we say if we return something from a response that just includes all of the data that matches a specific domain model, this OGM way uses a best effort approach to map all of these properties and to populate them already. So then, of course, I can have some tests to make sure that this is really the case and that I tried and coded all of my queries correctly. But then I really can go and say, well, please return all of this information and populate my objects already. And then my coffee bean just has the correct information here already, which you saw quite nicely in this REST response that I had. So when I just queried these individual beans, then you see that all of this data is already available. And then it is mapped here, in my case, by JSONB, by a Quarkus approach to a JSON response here. So this is then, again, we're in enterprise Java land. But this is quite nice because then we can access all of the data here in a Neo4j database way. Okay, so this is how to access and run and include a Neo4j example. So all of that, of course, is available on GitHub. So I will provide you the link at the end. If you want to try out a Neo4j database, the easiest way, of course, is to run it locally. I usually do this in Docker containers. I included an example here as well. What you can also do if you want to run this in a cloud way, this is quite nice. Neo4j offers, it's called AuraDB. It offers a cloud approach where in the easiest or smallest tier, this is available for free, where you can say just start it up in the cloud and then you can load data into it and you can query it and connect to it. So there are examples here for that as well. Or in the cloud, if you use a Kubernetes cluster, then there are different approaches to run Neo4j, of course, also in Kubernetes. There is a Neo4j Helm chart available, and I also included and created some content here. So I will show you a link for this on my blog at the end as well. So I have some examples and videos for Neo4j, especially how to deploy a Neo4j cluster on a managed Kubernetes. So this uses a Kubernetes cluster where then you can use the Neo4j Helm chart to deploy either a cluster or a Neo4j cluster, which is Neo4j multiple instances, or a standalone, a single instance there. And also in the future, there will be a Kubernetes operator, I heard, so there will be more approaches available. Basically, what you can always do is run your Neo4j instance in a Docker container and then run them in any way that you need. Of course, as always with databases, you need to take the persistence into place. So you need to have something like a persistent volume, et cetera, and some approach to manage it, as always. As an alternative, you can have a managed cloud way, or you do it yourself, whatever makes sense for your way. So this is basically what I wanted to share mostly. You can get the code online if it's interesting for you. You can check out the services that I'm offering on my website if you need help with a project, either with Java Enterprise and Quarkus in general, or with Neo4j and graph databases in particular. And first of all, thank you very much for your attention. So these links are the ones that you just need to save and need to follow. So especially the first one, if you want to try out the code yourself on my GitHub. And then also, if you follow me on Twitter or go on my blog, you will see some content there on Neo4j and also on Quarkus. Of course, I also have a YouTube channel where sometimes I create stuff like that. So I hope this was interesting, and I hope this was helpful and maybe with interest, maybe to try it out yourself with Quarkus and Neo4j.
Sebastian, thank you very much for such interesting and really useful session. And I can see enough questions from our participants. So would you mind answering some of them?
Please, yes.
Okay, good. So I think the most interesting part was, especially for me, it's regarding the dApps parameter and also how Neo4j handles cycles.
Yes, that's a good question. So with cycles, well, first of all, with a cycle, you can create a cycle. You just need to. So basically, now I need to be sure that I say the correct thing. But as far as I know, you can even build cycles similar to what you could do with Java objects, right? You could have two objects pointing at each other. The question is actually whether or not that makes sense. So I have an interesting response to that because we had this in a project where a cycle was usually a sign for a bug where you don't want to have a cycle because usually in a domain model it doesn't make sense, right? If you say you have something like a user pointing to another user, like maybe something like Facebook, you're befriended with this person and this person is befriended with that person, then you would rather instead model it with a single arrow and not with two arrows, something like this. Or in a bigger graph, it might or might not make sense. What I can say, it depends on your domain model. If this makes sense, from my experience, depends what you're doing, but usually maybe even not, unless you have a bigger graph where you say, okay, this one is connected to that, and this one is connected to that, and then the cycle closes. It might make sense. So this works technically, but then it depends what you're doing. And of course, if you have something like a recursive algorithm then on your data, you need to be careful because then you go into an endless loop or into a Stack Overflow. Because if you map this there, in general, this works, but usually it is a sign for a bug. What we did actually once was to create a cycle detector, because then we say, okay, here it must not be a cycle. So we loop through all of the data and see if we can find one, because then this should be a red flag.
Cool, thank you.
And I'm afraid we're running out of time, so we have time only for one more question. Maybe it's pretty simple, but what are the best matching cases to use Neo4j? And what about drawbacks?
Let's start with the drawbacks. The drawbacks is a lot of developers don't know it that well as they know relational databases, right? Because most developers know some sort of SQL or have worked with these databases. The tooling support is actually, for Neo4j, I think it's really good. But of course, the ecosystem is not as big as, let's say, Postgres or something else. So it's just based on the popularity. And a third thing is in the code and with Cipher, most people are just not as familiar with it. So it's a little bit different way of modeling the data and different way of thinking. As the positive things where it really shines is anything with, like, a recommendation is a good example, where you have a lot of complex set of criteria or properties that you want to select on, or where you have an access model. Because a lot of indexes in database work like a tree or work like a graph, right? So where you have an access model where it makes sense to go through some hoops to then search and select for your data. For example, something like you have a task management application, and then you say, give me all of the tasks from a date. So you might actually use a day or a date as a node and then say, okay, from there, just use it as an index. So for example, as opposed to your usually domain objects, you can put in more nodes that only serve as index or as access nodes, where then you say you know the ID or the data, and then you can access all of the other ones that are connected by the arrows. So then you can, it's a little bit different way of thinking, but then you can really have a very effective access ways for your data that you can then query. So especially on the query side, it's really powerful.
Thank you, Sebastian. It's good enough. Mm-hmm. And it was a great session. Live coding. We appreciate your participation and your support for Ukraine.
Thank you very much.
Have a nice day.